All right, here's a Venn diagram, right? And we are given a sample space and we're given 2 parts C and D. Now they say to us, write down the numbers that are in set D. Can you guys do that for me in the chat, please? I want everybody to write down the numbers that are in set D. Good. Alexander, you're correct. It's 6, but it's not just going to be 6. What else is also in set D? Beautiful, Jared. Well done. Beautiful. Good. Remember, guys, when we're looking at set D, we are looking at this whole circle. The full circle. Good. So we will have 6, 5, and 9. That is what is in the set D. Okay, beautifully done. Excellent. Now, let me ask a question before we answer this next question. Okay, this question here says C, D. What does this thing mean? What does this funny looking symbol stand for? Who remembers? Ah, Unati, you rock star. Beautiful. This is union. This is a union, correct. It's union. And what does union actually mean? Ah, Nomfundo. Guys, I feel like my job here is done. Good. Union means all. So we're looking for all the numbers that are in either set C or D. What are those going to be? Correct, Anotida. Beautiful. Good. Okay, you can either be in set C or set D. You don't technically have to be in both. You can be in either of them. Right, so I'm going to write 1 and 4 and 5 and 9 and 6. Correct, all of them. Because the only criteria you have to meet is that you are in one of the sets. You don't technically have to be in both. Gundo, teacher Nels is going to help you out in just a second. Okay. Teacher Nels is going to help in just a second. All right, let's talk about this last one over here. Right, this says C with the tiny little apostrophe. Who remembers what does the apostrophe mean? Who remembers? Correct. It's the complement. I love how everybody's just giving me the correct answers. Beautiful. Good. It is the complement. The complement, or we also call it not. Right. It's the complement, or we call it not. So basically what we're looking for is everything that is not. Yes, it ain't gonna happen, or ain't in C. Correct. So everything that is not in C. Now I've highlighted C. What is not in C, guys? Correct. Beautiful. Good. I know that C naught is going to be 6, 11, and 7. Ah, beautifully done, guys. Amazing stuff. Excellent, excellent work. Okay, I'm glad everybody's with me. Nobody's finding any of this difficult. Love to see it. Beautiful work, guys. All right, give me a thumbs up if you guys understood everything that's just happened in this whole exercise. Give me a thumbs up in the chat. Thank you, Jared, for writing thumbs up. Great. Easy stuff, guys. Easy stuff. Ngazi, teacher Nels is going to help you figure out what's going on with your blank screen in just a second. Thank you very much. All right. With that being said, welcome to Watobe, everybody. My name is Teacher Coco. For any of you who are joining us for the very first time today, I'm going to ask somebody to do the rules for me. Hi, Naledi. How are you doing, my sweetie?
Hi, ma'am.
Hi.
I wanted to ask something related to the Venn diagram.
Okay,
so
go ahead.
We started with Venn diagrams, but then there's one with only one circle, and then the one that you did now, and then there's another one with 3 circles inside.
Correct.
So
okay, there is an example with 3 circles that we can do, but that's going to be if we have the time. Okay. I do need to get through something a little bit more important, and that's the addition rule and the multiplication rule today. So if we do have the time to go to 3 circle Venn diagrams, I do have one, and we will get into it. Okay, all right, peeps. Without further ado, I'm going to put the next lesson on the screen. Okay, I want you guys to try these questions on the Venn diagram written here. Okay. Hello, DeAndre. Okay, I'm going to make it a little bit smaller so we can see all the questions. Okay, I'm going to give you guys some time to go through these 2 questions. When you're done, remember what we do. We always put our favorite emoji in the chat. I'm going to pop my favorite emoji in the chat real quick, and then I'm going to take Stephen and Mamelo's questions. All right, go for it, peeps. Hi, Stephen.
Hello, ma'am.
Hello, Stephen. How are you doing?
I'm good, and you, ma'am?
I'm good, thanks. What's up?
Ma'am, I just wanted to do the classroom rules, ma'am, but it's fine. I wanted to ask you if I can do them next week.
Okay. So, because you said that, Teacher Nels is going to write your name down, and now you can't escape it, because the next lesson, it's your turn to do the rules. I mean, it's the way the classroom works. When you put your hand up, time, it's your turn, and you have to be on time, Stephen. You're not allowed to be late for class next week, Monday. Okay.
And then on Wednesday, Mawanda will do the rules.
Mawande.
On Wednesday, yeah. Monday it's Stephen. Wednesday.
Yes, Mawande, we got you. Mamelo, what's up, my sweetie? Hello, Shaden. Welcome. Hi, Mamelo.
Hi, ma'am.
Hello, my sweetie. What's up?
I wanted to ask about how do we calculate percentage, because I was writing today and I kind of like have a problem. I don't know how do these people calculate percentage.
Okay, I'm not quite getting that. I heard you say calculate something, but I'm not 100% sure what you asked me to calculate for. Okay, I heard like bits and pieces. Can I ask you, because your audio is breaking up a little bit, can I ask you to maybe pop that question in the chat, and I will definitely address it as soon as I possibly can. Okay.
Hey, ma'am.
Okay, thank you, my sweetie. Just pop your question in the chat and then I'll take it from there. Okay.
Okay, ma'am.
Thank you. Slay Queen, how are we doing? Guys, the Queen is here. For our newbies, I have to give her an introduction because, you know, she's literally the drama queen that we all want, that we never knew we needed, but here she is. All right. The person I'm about to unmute is the spokesperson of Watobe herself. The Slay Queen has arrived. Kama, how are you doing? Oh, look at me. I muted you. I'm so sorry. Unmute.
Hi, ma'am.
Hi, my sweetie. How are you doing?
Oh, ma'am, I'm barely scraping through it, but it's fine.
Sweetie, I understand. It's like the midweek blues, but we will be perfectly. I know. Sometimes it is kuningi and getting kuningi. Okay.
Always, ma'am, always.
I agree with you.
I was going to ask, so in this lesson, are we going to get through, well, today we were doing the topic that we're on, the Venn diagrams. And then like, my teachers just decided, you know what, let's shock them all. Let's give them, you know, a roller coaster ride, just whack, out of the pebble. So now, like she draws like the Venn diagram, right? But then this time there were 3 circles. And I was like, there's no ways.
So I'm realizing that many of you probably did that. And I do have an example of that today. So we are going to get through that at a point today.
Perfect.
Yes. Okay, I've got one.
I mean, like, I understood it, like I was still panicking.
Okay, we'll go through it slowly. Remember, it's in the way that these things are written. Okay, but we'll go through it. It's always lovely to have you here, Slay Queen. Lovely to have you. Excellent question. Oh, I think I'm going to have to do that three circle question now because so many of us have it in class. Tanda, what's up?
Hello, ma'am.
Hello.
I have a question. So basically, our math teacher came back today because we were taught by a previous teacher. Then he told us that probability is about gambling. Is that true?
To an extent, yes. Because if you understand how numbers work, you can, to an extent, pick up how to gamble. I'm not saying it's a good thing. It's technically a crime to count cards. But if you are fast enough and you can count cards, you can play things like poker at a casino and you can get away with money. However, there are gangsters watching those cameras to make sure that you're not counting those cards. Okay, so it is true. And I'll explain and I'll show you what they mean. Okay.
I'm gambling. All right.
See now, I was trying to be nice, but now you're starting things. See what I mean? Okay. Gamblers, people who gamble for a living can actually count cards and they know how to use the probability to find. Yeah, and I'm just like Mawande. I lose a little bit of money and I'm like, I'm done. I'm too emotional to be a gambler. I could never. All right, let's talk about the answers over here. Any volunteers to give answers? I'm happy to give answers anyway. But if anybody would like to go through these questions with me, Barbara, yay! I love to see it. Barbara, do you want to unmute and have a conversation with me? How are you? Hello. Sure, Barbara, you're going to have to check your mic settings for me, my sweetie, and make sure that your mic is actually connected through audio so we can hear you. Okay, but in the meantime, I'm going to ask Mawande, do you want to go through these questions with me?
Hi, ma'am. Can you hear me?
Yes, I can. Yes, let's go.
Okay, so for the first question A, it's gonna be 9, 4, 25, 16, 36, and 5.
Okay, this is where I thought we might look a little bit different. Now, have a look quickly, Mawande. This is intersection, right? This one is called intersection, and this one is called union.
Yeah,
so remember, intersection means correct, the in between, right?
So
and the union, the one between any or, right? So in this case, what will the intersection of A and B?
9 and 4, ma'am.
Correct, it's 9 and 4. A intersection B is just going to be 9 and 4. Beautifully done. Okay, let's talk about the union. Now we know what the union is. Yes?
Yep. Yeah.
A union, give the numbers.
So it's gonna be 9, 4, 25, 16, 36, and 5.
Beautifully done, and 5. Let's talk about this last one over here. The last one says a complement. So what do they want from us?
Anything but A, or anything involved with A. So it's gonna be 17, 5, and 40.
Beautifully done. Good. 17. Now I'm writing 15 because you said 5. Okay, 17, 5, and 40. Just pure gold, my dude. Beautifully. Amazing. Amazing stuff. Excellently done. The rest of you guys, if you still have a question, I want you to keep your hand up. But if you don't have a question, I'm going to ask you to put your hand down because we're going to go into the more complicated Venn diagrams. Okay. All right. I want everybody else to read this question that we've got over here, right? Write down the information that we're seeing, and then we're going to get to what this actually means for the question that we're doing in just a bit. Okay. Sposetu, how are we doing, my school? Hello, Sposetu. Okay, I'm not getting an unmute there. Yandisa, how are you doing, my sweetie? Hello, always lovely to see your face.
I'm fine, ma'am. Thank you.
What's up?
Today, let's go back to the Venn diagram.
Okay.
It's B. B, I'm left, like I'm left.
This one here, B.
Yes.
Okay, so B means union, right? So let's say, for instance, we're in a class, right? And A stands for athletics, right? Athletics, and this B stands for basketball. Now, right, if I had to ask you, do you play, if you, let's say we're talking to the Watobe class, if you take athletics or basketball, put your hand up, right? What that tells me is everybody in the athletics part and everybody in the basketball part will put their hand up, especially people who play both sports, they will put their hand up. That's why we're saying the union is all, it's all of them. Whether you play athletics or it doesn't matter. Both of them need to put their hands up. Okay. Okay, so that is the union all. Now in this one, intersection, you have to play, the rule is that you have to play both sports. You must play athletics and basketball. Which one that play both? It would have to be in the middle over here, correct? Because they play both. If you don't play both sports, you're down. Okay. Does that make sense? Are you with me there?
Yes,
Okay. Does that answer the question? I hope it did.
Yes.
Okay, good question. Very good question, by the way. Thank you, Yantisa. Princess, what? Okay, I'm gonna go back here and I want you guys to question. Hello, my sweetie.
Ma'am, I wanted to just like in general confirm. So when you say the complementary, like on the previous question, complementary of A, it basically just means no, even the intersection won't be involved. So basically the intersection is a separate thing.
Well, not particularly, because if we look at this, the intersection is part of A. Remember, A and B share the intersection. So the only numbers that are not of A will be the ones not in the circle.
Oh, so the complementary of A is including the intersection and
Yes,
A in general.
because the intersection is part of the circle A.
Okay. Yeah, thank you.
I'm glad that answered the question. All right, let's look at this next example. All right, now I want us to note something, Mfundo, before I take your question in just a second. This question over here says, in a class of 24 students, 12 play piano, 13 take guitar, and 4 students play neither instrument. Now, here's the problem, guys. There are only 24 of us in the class. There are 24 students. If I add up these numbers, how much do I get? Correct, Mfundo. Good, Tamia. Good. I get 29, which doesn't quite strike a thing with me. Right. What this tells us, what exactly does this tell us? Hi, Slay Queen, what does it tell us?
Ma'am, it tells us that, wait, does that correct me if I'm wrong though? They haven't given us the outlier, so we need to work out for the outlier, right?
Okay, correct. Well, we're not going to call it an outlier, right? Think about this. They've said that this many people play piano and this many people play guitar. What have we not accounted for here? We've also accounted for students that play neither, but what have we not accounted for?
The students that do nothing.
Well, we do know the students that do nothing, there are 4 of them. Which students have we not thought of? Check in the chat.
The students that do both. Oh my gosh. Oh.
Hey, the students that do both. Good. Because just because you're playing the piano doesn't mean you can't play the guitar either. You can do both. Okay, so I'm going to ask you, Slay Queen, do we know how many students play both? Do we know how many of them? How many students play both?
Wouldn't we need to say 29 minus 12 minus 13 minus 4?
Well, if we did that, we just get 0. Okay, because 29 is this, right? But we don't actually know how many students play both, right? So we're going to name this. We're going to name it X. Okay,
X.
Because we don't know what it is. But we know that some of the students play piano. So together, all together, piano needs to equal 12, right? So let me ask you, Slay Queen, if this X in the middle was 2 and the kids who play piano all together was 12, how much would we have over here?
Oh, 10.
Correct. How did you get to that answer?
She explained it today in class, but like you normally add. Sorry?
Right? We would normally add, right?
Yeah, you normally add.
We're just going to go 12 minus 2, and that would give us 10. Agreed?
Yes.
Good. So now, if this is X, how do we figure out how much is over here?
We'd need to say X minus 12, if I'm not mistaken.
Not in that order, in the other order.
12 minus something is equal to X.
Okay, correct. So we're going to say 12 minus x because that will give us the whole of the piano players. Okay. Now let's think about the guitar players. Guitar altogether is 13.
13.
Right. What do we know about this part over here? What did that have to be?
11.
Well, we don't know what x is. So how do we figure out what this is? We're going to take the same approach. It's going to be 13
minus x.
Correct, 13 minus x. Okay, and let's not forget the 4 who don't play anything. Where do they go?
They go on the outside, ma'am.
Correct, they go in the rectangle over there. Okay, so we know that all of these numbers together need to equal how much?
29.
No,
If
not 29.
24.
How many students do we have altogether?
24.
Correct, 24. So what we can do now is we can say all of this added together must give us 24. So I can
24.
go 12 minus x plus 13 minus x plus x. Don't forget the x in the middle. Plus 4. All of this must equal how much?
24.
Correct, 24. And then can we solve for x?
Yes, of course we can. We can always solve for x.
I'm going to give you a second, do some magical mathematics maneuvering and tell me what is x? What is x equal to?
So ma'am, we would take 12 to the other side, 13 to the other side, and 4 to the other side as well.
Good.
And then after that, you would add all the x's together.
Good. So I've got negative x minus x plus x. What would that give me?
You have negative x.
Correct. Negative x is equal to, now I've got 24 minus 12 minus 13 minus 4. What does that give me? Negative x is equal to?
Ooh, isn't it going to give me an integer?
It should give you an integer.
Minus 5. Yeah, minus 5. Because
right. But we know we're not looking for negative x, we want x, so we're going to divide through by a negative, right? That means x is equal to?
X is equal to 5x.
Correct, 5, just 5, right? Because all we've done is divide by negative, so the negatives will cancel. So x is equal to 5. So we then go back to our Venn diagram, move this part, x is now equal to 5. What does that tell us about 12 minus x? What is that equal to?
Isn't it 8?
12 minus 5?
7.
7. And then 13 minus 5?
8.
8, correct. Okay, I saw a question just now. So do you see how we do that? Now, if we add them all together, 7 plus 5 plus 8 plus 4, what would that give us?
7 plus 5 plus 8 plus 4, 12, 20.
Not 20 plus 4.
Oh, 24.
24, correct. That finally gives us 24. Okay, so okay, so that's how we figure out how much is on each side. Do you guys do something similar to this at school?
Oh no, ma'am, she skipped all of this. She literally skipped all of this. When I tell you this is the foundation, she built the house on a sandy land.
No, Masi. Okay, but this is the method that we're going to use to solve for these questions.
Yes, ma'am.
Okay, all right. I'm just going to answer some of the questions in the chat real quick. Well done, Slay Queen. Nicely done.
Thank you.
Okay.
Thank you. Yeah.
Okay, somebody's saying here, why do we do negative x? And will we always do this? And how will we know when to do this? Okay, I'm going to show you in the next example, person who's asking me that question. Okay, the reason we do negative x is because negative x minus x will give us negative 2x plus x will leave us with negative x. Okay, and that's why it's negative. It's not particularly that we want it to be negative, the equation makes it so. But the other questions, yes, we will use this. Alexander, I'm very curious to know the other way that you guys do that. Warona is asking us, how did we get 7 and 8. Well, if x is equal to 5, then 12 minus 5 would have to be 7, and 13 minus 5 would have to be 8. So Waruna, I hope that answers your question.
Sorry, ma'am.
Okay. Yes.
So today I asked my maths teacher if like there could be like a possibility where we could have 3 circles, right? And then the one on the left is in contact with the one in the middle, and the one on the right is also in contact with the one in the middle. But then the ones on the left and the right don't touch at all. Is that possible?
Yes. Yes, it is. It's called a conditional probability, but we don't do that in grade 10 or grade 11. It's something that you mostly see in university. Okay, it's not something that would happen here.
Oh man, we did that today.
How, Sway? How? Okay, I'm gonna bring up another question just now and we'll see what it is your teacher's making you guys do. Okay,
Sure,
we'll talk about it. Okay, we'll talk about it. All right, let me quickly. Okay, just give me 1 second, guys. Okay. Fundo says they have a question. I'm going to take your question in just a second. While we do that, I want everybody else to look at this over here. It says here, a PE test has 2 sections, theory and practical. Everyone in the class who took the PE test passed at least 1 section, right? 62% passed the theory and 86% passed the practical, right? Before we even begin, if we're calculating for things in percentage, what do we know our sample space must equal to? What must our sample size equal to? Correct. It should equal to 100%. So I want you guys to take that into consideration when you are answering this question. Okay. While we do that, Fundo, what's up?
Hello, ma'am.
Hello, my boy. What's up?
Ma'am, I just had a question for the previous question.
Okay.
So, ma'am, do we have to always solve for X? Can't we just, because they said we have 24 learners in the class. So what I did was I took the 12, I took the 13, and I took the 4 and I added it up, and that gave me 29. Then I took the 29 and I subtracted it from the 24, and that gave me 5.
So that gave you the answer you were looking for in the middle. Okay. That could work, but you'll see when we get to 3 circles that it's going to be a little impossible for you to do that. Okay.
Yes, ma'am.
All right. If that system works for these kinds of questions, sure, go ahead and use it. I'm going to try it and see because I've never seen it used before. But if it works, then we'll use it. But I can guarantee now for three circle Venn diagrams, it's not going to work. Okay.
Yes,
but we'll get there.
Thank you.
All right. Good question. Okay, Sinako, what's up?
Yes, ma'am, I got lost. Can you please re-explain the one that you didn't?
The one that we've got on the screen right now.
No, ma'am, the previous one, ma'am.
The previous one. Okay. Can I, instead of using the previous one, can I use this one to explain the concept to you again? Okay, because I don't want people not seeing the question because I want everyone to try it. But I want you to keep your hand raised and you and I are going to speak about this one together as we go. Okay?
Yes, ma'am. Thank you, ma'am.
All right. No problem. Okay. Keep your hand there. I want everybody to pop their favorite emoji in the chat when they're done or if they feel like they can't continue with what's happening. Shaden, what's up?
Ma'am, something just came across my mind for some reason. I just want to say I like what's going on here is that we do the topic, like we haven't started with this topic yet and we're still currently busy with stats, which is something that really helps a lot. Like it helps like a lot because like we can do class tests and stuff like that and I won't even struggle or anything because I know that we did it on Watobe already.
I love to hear it. I hope it's actually, you are understanding what I'm saying, right? So it's not just like,
yes,
you're not hearing me and you're just like, we did this already at Watobe. I hope you're actually understanding. Yes?
Yes, ma'am. And also another thing is sometimes my sir doesn't really explain things like for you to understand properly. And that's when I'm just like, teacher Coco is the one. She is the one, because like sometimes I'm not understanding what the sir is saying. Like if it wasn't for you, ma'am, I don't think I would understand what that sir was saying. Really, like really.
Oh my goodness, stop. I mean,
Yeah, no.
but thank you.
Watobe is
But I'll take the
definitely
compliments. Don't stop. Thank you.
Watobe is definitely better than the school, honestly. Like
I'm
if Watobe
so
could be
glad.
school, if Watobe could be school, I am sure it would have
You
been
know
better.
what? Unfortunately, I'm on levels. So even the school I'm at, I'm at a level, but it's okay. I'm so glad, my sweetie. You know what? That's part of my job. I want to make sure that you understand by the time we get to the end. Okay. But
Thank you so
I'm going to ask Sinako to help me with this question. Thank you, Shaden. You always know how to lift my mood. I love it.
Thank you, ma'am. Okay.
Thank you. I need the kids at my school to be on me like this. You know what I mean? I love this. Okay, Sinako, let's talk about this. Let's talk about this question. Do you want to unmute for me? Okay, so think about what they're telling us. I've named this part T for theory and this part P for practical, right? How many kids pass the theory section?
62%.
Correct. So theory is equal to 62%. What about practical?
83.
Correct, 83%. Now, here's the problem. How many passed both of them?
We're not given none.
We're not given that. So what are we going to name it? Because we don't know what it is, we're going to name it?
X.
Correct, we're going to name it X. Now, because we know that this whole circle has to equal 62, what does this tell me about the theory part only? That's going to be 62
minus X.
Beautiful. 62 minus X. And what about the 83%? What about the practical part? That's going to be 83
minus X.
Minus X. Beautiful. And we know that all together it needs to equal how much?
100%.
Correct. So I want you to give me a formula that's going to make all of this equal to 100%. How are we going to write that sum?
Then can be minus the 83 and the 62 to 100.
Well, yes, we can, but we need to set up an equation first, okay? Because remember, all of these added up together must give us 100. So I'm going to go 62 minus X plus, what can I add to 62 minus X?
Can we add the 83 minus X?
Correct, plus 83 minus X, what else are we missing? Plus?
Plus, can we say X then equals to 100%?
Just, I bribe my kids in my class with sweets, and if you were sitting in my class right now, I would throw you a sweet because you did that. Excellent, good, excellent. What is our next move? What's the next move?
We take all the units to the back.
Correct. We're going to take all the numbers over to the other side. We're going to transpose, right? So, and then I'm going to add like terms. I've got a negative X minus X plus X. What is that going to give me?
Negative X.
Correct. So negative X is equal to, now I've got 100 minus 62 minus 83. What is that going to give me? Negative X is equal to how much?
Negative 45.
Correct, negative 45. So this is equal to negative 45. And then I don't want negative X, I want X. So I'm going to divide by negative, divide by negative. So X is equal to?
X is equal to 45.
Beautiful, good. So X is equal to 45. So we're going to go back to our drawing, Sinako. We know that X over here in the middle is equal to 45. What about the theory part? What must theory now equal to?
You wanna say the 62 minus the 45.
Beautiful, 62 minus 45. And what about the practical part?
83 minus 45.
Excellent, 83 minus 45. You need to give me answers for these now, dude. You can't just say that.
X
How much?
minus 62 minus X will give me 17. Then 83 minus
Correct.
X
This
will
is
give me
17. And on the side, it's
38.
38. Look at you whole rock star.
Thank you, ma'am.
Beautifully done. Like no error, no mistake, nothing. Just excellence. Well done. Well done. Excellent stuff. Love, love, love it. Okay, give me a thumbs up, guys, if you understood everything Sinako and I went through. Give me a thumbs up. Okay, and now I'm just realizing, I can't remember who it was. Alexander, I think it was you who said you used a different method. And I just realized your guys' method does actually work. So you can go 62 plus 83 is equal to 145 minus 100. And that would also give us 45. Agreed, that works. Okay, but like I said, it's going to get a little bit more complicated as we go along, and we're not going to be able to do this all the time. But for now, excellent. This method that you guys are doing here works 100%. Okay. All right. Eliche says, ma'am, why is T equal to 64? Oh, it's not. Eliche, it's not. It's just my handwriting. My handwriting sucks. Okay, it's not 64. It's 62. It's just ma'am's handwriting. Okay, sorry about that. Yes, Oratile, to an extent it is, but I'm going to show you why we can't particularly do that in the next example. Okay. All right, peeps, are we ready for the next example? Give me a thumbs up if you guys are ready. Love, love, love it. Love to see it, guys. Okay, excellent stuff. Let's get to the next question. Okay. We're going to do the probability in just a second. This is the example we did the other day. We don't need that example. All right, let's look at this example over here. Okay. I'm going to have to make it just a little bit smaller. Oh, all right, Slay Queen, I'm going to be with you in just a second. Everybody else, I want you guys to read through this example and make sure you're understanding what's happening. Slay Queen, what's up?
Sorry, ma'am. Going back to like the other example, but like you don't really have to like on the screen.
Okay.
I was just going to ask. So remember when you said negative 45 and negative x, but we don't want a negative x. So do we divide by negative x, or do we just divide it by -1 in order to get
just -1? Just -1.
Okay,
because
perfect.
dividing by negative is the same as dividing by -1, but we divide by -1 on both. Okay.
Perfect. Because like I was a little confused. Like I thought like I literally did something. I could just feel it in my bones, you know?
No,
like, I could just
no. It's just me. I left out the 1. So it literally is -1. Okay. It's not negative x. It's me dividing by -1.
Okay, ma'am. Thank you so much.
Okay. All right. Good question. Excellent question. Refilo, what's up?
Hi, ma'am.
Hello, Masudi.
I just wanted to ask about the last question because there were 3 x's and we just went to 1 x just like that. I thought it was gonna be like 2x or something like that, but
Okay.
I don't know how we do that.
Okay, let me show you. It was actually 3 x's that look like this: negative x minus x plus x. So we know if you negative x minus x, how much would that give us?
0.
Not 0. This is the same as negative 1x minus 1x. What would that give us?
Positive.
No, we're just minusing, Masri. So it's the same as me saying -1 minus 1. What would that give us?
1. No, I don't know, ma'am. 2x.
Check in the chat.
Negative 2.
Correct.
2x.
So I'm going to have negative 2x plus x. So now I have negative 2 plus 1. What would that give us?
Negative 3.
I'm adding 1. If I owe you 2 rand and I pay you 1 rand, how much do I owe you?
Oh, so it's going to be negative 1.
Correct. That's where we got the negative x from. Okay, because of the negative gave us negative 2 plus x gave us negative x. Okay.
Yes, ma'am.
All right, my sweetie. Okay, if it's still a bit like challenging, just do it on a calculator. Get it over and done with. Okay, I see everybody saying I'm glowing. I know I look pretty. Love it. Thank you, guys. All right, let's talk about this example that we've got here. Siamtanda, what's up?
Ma'am, I wanted to talk about I wanted to talk about this example.
This question here.
Yes, ma'am.
Okay, all right. Let's go through it together. Do you want to explain to everybody what we're going to do, or do you know what we're going to do?
Oh, I know what we're going to do.
Okay, beautiful. Okay, I'm going to read and you're going to tell me what to write. Okay.
Okay.
Okay. So, okay, first thing I'm already noting is that there's a mistake in our sample size, right? Because it says here, in a roadblock, 102 cars were checked for roadworthiness, but over here they've told us that our sample size is equal to 104. So please, guys, it's not 104, it's 102. Okay, let's start with fixing that. All right, then it says 34 cars passed the test and the rest failed because of defective brakes. Defective brakes is one of them, lights is the other, and tires. So if you guys look at our Venn diagram, there's B for brakes, L for lights, and T for tires. They've done us the courtesy of showing us that the 34 cars that passed the test are on the outside. So that part is already done. Okay. Now it says 30 had faulty brakes, 30 had smooth tires, and 33 had faulty lights. 7 failed on both lights and tires, right? 10 failed on both lights and brakes, and 11 failed on both brakes and tires. Siamtanda, what is all of this telling us? Let's think about this.
So, ma'am, first we have to start with, in the Venn diagram, we have to start with the point in the middle where all 3 circles are intersected.
Yes. All right. So what are we going to put there?
30.
Why are we putting 30 in the middle?
Because all 3 had faulty brakes, all 3 had smooth tires, and you get what I mean, man.
Not quite. Okay, so think about it. They're telling us that 30 of them had faulty brakes, which means the whole of this section needs to be 30. And they're saying that 30 of them had smooth tires, so this whole section needs to be 30. And they're saying that 33 had faulty lights. So all of this whole section must be 33. But the problem is the intersections, correct?
Yes, ma'am.
Are you agreeing with me? Okay. Now, what does this circle or what does this tiny intersection right in the middle tell me? Which cars go in the middle part over here?
All of them, ma'am.
What do you mean all of them? It would have to be the cars that did what? That failed? All 3 tests. Agreed.
Yes.
Do we know how many cars that is?
No, they have not given us.
They haven't given to us. So what are we going to name it?
X.
Correct. We're going to name it X. So let's work our way backwards. Okay. Now it says here, we've done that part. We've done the hard part. It says 7 failed on both lights and tires. Okay, I'm going to go to the intersection for lights and tires. There is the intersection for lights and tires. Now, this whole section needs to equal 7. So what do we know about the tiny little section over here? How much would that have to be?
7 minus X.
Oh, you get me. 7 minus X. Good stuff, right? What about this part where they say 10 failed on both lights and brakes? We know lights and brakes is over here, but what happens to this tiny little part over here? Okay, Jared, I'm going to explain in just a second. It's going to be
10 minus x.
Correct, 10 minus x. Okay, and then it says 11 failed on both brakes and tires. So we know that this tiny part over here will have to be
11 minus x.
11 minus x. Okay, for those of you who are still a little confused as to why we're saying 7 minus x, 10 minus x, okay, let's think about this. If we have three cars that failed all three tests, and they're telling us that 7 of them failed lights and tires, we know that because there's 7, we've already counted 3, which means this would have to be 4. But now, because we don't know what this number in the middle is, we're calling it x. We're calling it x, which means if we want to figure out how much of that 7 was, we need to go 7 minus x. Give me a thumbs up if everybody understands why we're doing it this way. Is everybody with me? Good, okay. Correct. Somebody says to me, we're calling it X because they haven't told us how many cars failed all 3 tests. Correct. Yes, and Caitlin says, do we add all the values together to get the answer for X? Yes, we are about to get into that. Okay, Sinobushe, I'm going to repeat one last time. Okay, if we don't know how many vehicles were in the middle, but we know how many vehicles are here all together, we're going to call that middle part X. And because this whole section needs to equal 7, this little part over here needs to equal 7 minus X. It's the same as if this middle number was 2, we automatically know that this number, because it needs to be, all of it together needs to equal 7, we automatically know that this part is equal to 5. Okay, is that making sense, Sinobushe? Give me a yes, ma'am, if you understand which part I'm talking about. Okay, all right, Siamtanda, beautiful. All right, Siamtanda, let's continue with our assault on this. Okay, now it says here, remember the other thing that we had to have to answer, right? We know that this whole section over here must equal how much? How much must it equal to, Siamtanda? You're muted.
33, man.
33, correct. Okay, but if we look at what we've got over here, a tiny portion of it has already been accounted for. How many people can we account for in this circle already?
You can account for 2 people, man. 2.
Not 2. Have a look on the screen. We've already counted 7 people. We've already counted 10 people. So of that 33, we've already counted 17 of them.
Oh, 17.
Correct. So how many of them are actually left?
It's going to be 16.
Correct, 16. Okay, but we also have to account for the fact that this 16 will also include the people that are in this particular bracket. Okay, so that to make sure that we do not count this dude twice. We don't count him twice. We're going to take 16 plus X. Okay, if we don't do that, we're going to end up counting that middle part twice. Okay, watch what I mean by this. Here's what I mean. If I know that this entire section over here needs to equal 33, I can go 10 minus X plus 7 minus X plus X. How much must all of that be equal to, Siamtanda? In this one circle,
33.
How much must all of that be equal to?
33.
33, correct, 33. Now let's do some mental maths, right? I'm going to take 16, negative x plus x. What's that going to give us?
Negative x.
Negative x, good. And then I'm going to have 33 minus 10 minus 16. What's that going to give me?
16.
Correct, it's going to give me 16. But because I know that the negative x is already accounted for, I'm also going to transpose it. It's going to go over to that side, and I'm going to have 16 plus x. Agreed?
Yes, ma'am.
Are you with me here? Because we
Yes,
don't know
ma'am.
what x is yet. Right, so this missing part over here needs to equal to 16 plus x. Am I making sense?
Yes, ma'am.
Okay, let's try it for the next part. Let's try it for the next circle. Oh, and look, now I'm erasing answers. Okay, let's try it for the next section. Let's try for this section over here. We know that all the answers on this side must equal how much? 30, correct. So our formula will read 10 minus x plus, can finish the sum for me?
11 minus x.
Good, plus?
X is equal to 30.
Beautifully done, is equal to 30. Okay, now we're going to transpose. Yes, 10 will go over, 11 will go over, and we know that negative x minus x plus x will give us negative x. Agreed? Is equal to, and then I will have 30 minus 11 minus 10, which would give us
9.
Correct. So I'm going to have negative x is equal to 9, but because we don't know what the circle is equal to, we're going to take this negative x and transpose it as well. So the whole thing, what is left of it, is 9 plus x. Agreed. So this part over here will be 9 plus x. Now you have to give me the equation for that last part. Okay.
So it's going to be it's going to be 7 minus x.
Good.
Plus 11 minus x. Plus x is equal to 30.
Must equal to 30. Beautiful. And then we're just going to transpose, right? I know I'm going to end up with negative x is equal to, and now I have 30 minus 11 minus 7. Right? So negative x is equal to how much?
18.
Oh, not 13. Check again.
Oh, 12.
12, good. So negative x is equal to 12, but we don't know what the whole circle or what the whole circle is equal to. So we're going to take negative x over to the other side, and it's going to become 12
plus x.
Plus x, beautiful. 12 plus x. Nicely done. Now, my last question, because we do need to go. Siamtanda, how much must everything in this whole Venn diagram be equal to?
102.
Beautiful. So do you think we can set up an equation where we add up everything and figure out what x is? Because we now know that all of it must equal to 102. Do you think we can do that?
Yes, we can do that.
Absolutely. You're going to have to give me the sum. That's the last thing we're going to be able to do. And then we're going to compare answers in the next lesson. Okay, give us the equation. Give us the equation.
16 plus x.
Good.
Plus 12 plus x.
Good.
Plus 9 plus x.
Good. Plus.
Plus 7 minus x.
Good.
Plus 11 minus x.
Plus 11 minus x.
Plus 10 minus x.
10 minus x.
Plus 34.
Plus 34. We forgot one more. Plus.
Oh, plus x.
Correct. Plus x. And all of this must equal how much?
102.
Oh, look at that. Yo, what an equation. And you did that so well. Well done, Siamtanda. Excellent. Excellent. Amazing. Now, I can't find the answer because we're out of time. And guys, somebody needs to write to Watobe, tell them to make the classes a little bit longer because guys, like jiggy time is up. I don't know. But Like, Siamtanda, my dude, well done. Just amazing stuff. Amazing, amazing.
Thank you so much,
amazing.
ma'am.
Okay, Teacher Nels is going to drop the link to the quiz in the chat. Siamtanda, you are on next Monday. You're going to start us off by answering this question. Okay.
Okay, thank you, ma'am.
All right, you're very welcome. I'm going to answer this very last question. Somebody saying to me, Sarah, how do we know when we need to put X by the number? Because we have to leave X by itself. Okay, in this case, because when we get to this circle, we haven't solved for the full equation yet. We then know that we have to take X over to the other side. Okay, we haven't solved for the full equation yet, so X goes over to the other side. And also, if we think about it, the only information they didn't give us was the car that failed all 3 tests. That's why that goes in the middle. Okay. But I will explain again, don't stress. I'm going to explain again on Monday before we continue.